All right. Well, I'm coming to you from beautiful Washington State, and I'm very excited to share with you our agentic document extraction. So, a little bit about me. I'm a machine learning engineer at LandingAI. I've worn a lot of hats throughout my life. Spent about 10 years in management consulting, 10 years leading technical teams, 10 years in technology sales. I am self-taught as a data scientist, having originally studied chemistry, and my hobbies are tennis and board games. So if you're ever in the Northwest and you want to play tennis or board games, I am all for that. And I'm trying to figure out how to advance the slides. There we go. So I have a lot of content to share with you today. I'm really hoping that this will be kind of a comprehensive experience, both understanding what the product is, how you might use it, how we support our users, and then getting into some code and actually seeing it running live on a batch of documents towards the end. So I'm hoping that this webinar will be something that you can refer back to, watch on fast forward, share with colleagues, and it's really going to be kind of a one-stop shop like introduction to all of agentic document extraction. So we're going to start off doing some no codes stuff over here on the left, and then probably the back 40% or so will be working in code to actually use the API. This is a preview of kind of where we're going to end with the final example. So we will use the API to take in some product images as documents and actually just prepare this output table where we have nice structured fields that have been extracted from all of the documents. And we also have these chunk references, which is the visual grounding, which we're going to talk about. So that's a preview of what's to come at the end. We do a lot of like financial documents and medical documents, so it's also just a fun example. So what is agentic document extraction? So fundamentally, it is this piece in the middle. It is an API. You're going to make a very simple API call to parse, and you're going to get back extractions, enrichments, and field extractions as well. So this is going to work with any sort of complex documents. It doesn't require custom training on the layout. It doesn't require any sort of advanced data collection. It just works out of the box. Um, you know, most of our examples and real customers are not in the grocery space, right? So I want to preview just a couple of use cases here. So financial services is full of documents. So whether it's KYC, mortgage and loan documents, invoices, tax documents. So we're working with a lot of financial services companies around these types of documents. Healthcare also is full of documents, both documents that labs generate, that doctors generate, that patients bring from one facility to the next, that insurance agencies generate. So lots and lots going on in healthcare in these PDF documents. Shipping and logistics is another place where we see just a lot of paper being exchanged. So whether it's a bill of lading, a certificate of origin, a customs declaration, there's a lot of documents in a lot of different languages and a lot of different formats involved in shipping and logistics. And all of those use cases, kind of like financial services, healthcare, the shipping and logistics have in common is typically there's a large collection of documents that are being issued by a variety of source providers, and all of the layouts are different. So the content might actually be the same, right? On an invoice, there's an invoice date, there's a total amount, but the layouts are different. And so in many cases, the goal is to work with all of those different layouts and be able to map that to a structured, custom common schema. So this is really kind of the key benefit to some of those industries that I just shared. But we're also getting a lot of interest from people who are working in with archival documents or in library sciences. So here, like all of these documents are a one of a kind, right? We're not trying to extract and map them to a custom schema. In many cases, these have already been digitized in terms of like, somebody has already scanned them as a photograph. But now we really have the ability to extract much more detailed information out of them, including these types of kind of handwritten notes on top. I've already mentioned a couple of the key features. So parsing the information and the visual grounding, which will make more sense when we actually see it. Enrichment will also make more sense when you see it, but really applies to the figure types or a photograph or other things where there's an actual description of the item within the document. Previewed a little bit around field extraction, and then enterprise security. So if you think about those domains, financial services, healthcare, these are all places where there is sensitive information. So PII, PHI, there are various jurisdictions that govern data processing and data handling, from HIPAA in the US to GDPR in Europe. So we are able to provide all of these features with that enterprise level security. Also of note, we're not going to be working in the Snowflake user interface today, but one option for ensuring enterprise security is to run our agentic document extraction entirely natively inside of Snowflake. So if you're listening today and you are a Snowflake customer, that is one option to get that enterprise security. And it's going to integrate with Cortex Search. You can use Snowflake notebooks along with our services. So this is one option for that security layer. And then this is kind of just the acronym to remember before we actually get into the product. So FAST. We're able to provide a very fast API response, and we are also able to really accelerate your business process because you don't need to pre-train on any sort of document template. Accuracy, I do phone calls every day where people report like, hey, I've tried your product. It's by far the most accurate that I've tested. So we absolutely encourage you to do side-by-side comparisons. But if accuracy for domains like healthcare, financial services is of paramount importance, I think you're going to find really good results here. Trust, we've already talked a little bit about security. You'll see the visual grounding in a moment. And then we're trying to make this economical for you. Certainly in comparison to a manual process, you're going to find quite a bit of cost savings here. So let's go ahead and get into the demo. So some of you may have already spent some time on our website. So this is our product page for Agentic Document Extraction. A lot of the information that I just went over in terms of key features is recapped here. And there's also an excellent video from our founder and executive chairman, Andrew Ng. But you're basically just going to click on this white button to try Agentic Document Extraction. If you don't already have an account, it will ask you to sign up. And if you do have an account, you'll basically be taken to this experience. So we call this our visual playground, and this is really for previewing how well the extraction performs on any one of your documents. So I'm grabbing a document from my local file system. I'm just going to drop it in here, and we'll watch this kind of parsing happen in real time. So again, as I mentioned in the slides, the actual service we're offering is an API to replicate this process that you're seeing in the playground. But we're finding that people are really, it's really easy to do testing and also kind of visual explanations in the playground. So we got a response back here in probably 7 or 8 seconds, may have even been faster than that. And the first thing you notice are these bounding boxes on top of different chunks of the document. So part of our foundational model is first identifying the different sections of the document and then classifying them. So this is margin information. This is being extracted as a figure because it contains the logo. This is being extracted as text. And here we have a table. So everything in this document is clickable. So I can click into any particular region, and this is going to allow me to kind of compare side by side the accuracy of the extraction. And this is why people are really finding the playground the best way to compare accuracy, right? You can zoom in on different parts, makes it really easy. So the most complicated thing in this document is probably the table. We've put a lot of work into accurate table extractions. So tables with multiple header rows, tables with no grid lines in them, tables with like lots of mixed languages, which I'll show you in a moment. This is an example, from Tata, right? And so you'll also notice that just the way that the commas are inserted into the numerals is a little bit different, but definitely matches the original. All right. So that is the process. When you're in here, when you first open an account, you'll have multiple example files, and then we will also keep track of any of your particular files so you can refer back to them. A really nice feature here to share this is notice this sharing button. So by default, this document is not going to be public, but I can make it public and then I can actually send this link to, Adrian so he can check it out. So he would then not need to rerun the same document. He can look at this result after the extraction. In the visual playground, there is a limit of 50 pages for a document that you drag and drop, but there is no limit when you're using the API. So if you do want to test out a longer document, cut it down to 50-page chunks. All right. So let's take a look at some of these core examples. Okay, so here's the one that we just ran. I ran it in advance just to make sure. Here's an example from shipping and logistics, and this is starting to be an example where there are no real grid lines associated with the table. So, pretty straightforward cargo manifest. What have we got here? So here's a Schedule C as a text document. So I can actually, I've learned that if you toggle between the JSON and Markdown, you can bring back up like all of the bounding boxes at once. So you can see how this document has been parsed. I mean, the income section. What's nice about this table actually is that it understands that there's line 8 through line 27, even though it's a two-column table. So we've put a lot of effort into kind of human comprehension of tables, especially for tax forms. Here's an optometry example. What I particularly like about this one is not just that we get the prescription right, but this document has a lot of these checkboxes. And you notice that the checkbox are also extracted correctly from the original. So this is something that, traditional optical character recognition has not done well, as this checkbox extraction. So here's our first multi-page document. So here we've got 28 pages. This, of course, is a sample statement, but is very representative of the types of uploads that a loan processor might get. So if I'm applying for a home loan, I might need to provide, proof of income, proof of assets, right? So this is the type of statement that would often be uploaded for those types of organizations. And in many cases, they're only interested in the total balance and the date, and then verifying that the name matches the person who's applying for the loan. And this is really where field extraction is going to become the most relevant. So that might actually be a good chance to do some field extraction. So we've been spending time on the Markdown and the JSON, but we're going to switch over to field extraction on this example. And all right, maybe let's just start over. So if you haven't been to the playground in the last week or so, this will be new, and we're releasing new features all the time. So this document obviously has a lot of structured information, and I could start creating a schema that says, what is the name, what is the date, what is the total amount. But I can also start with a suggestion here, and I think I may have actually run this document before we introduced field extraction. So I'm going to go back to our Tata invoice. There it is. Okay, this one we just did together. So when we introduce new features, they don't always work on documents that you did like a month ago. So here's the Tata invoice that we just did. What I was looking for was this button to actually be live and valid. So I'm going to hit start with suggestions. So this suggested schema is being extracted directly from the contents of this document. And you see it makes sense. You know, what are the items on the invoice? What is the seller information? What's the banking information? So I'm going to go ahead and just accept and run this default. So this is really a time savings tool. If you already have your own custom schema, there's an option here to upload it. So if I have a schema in JSON, just upload it and try your own custom schema against this. So that extraction was really quite fast. So now instead of getting kind of the raw JSON response, I'm getting all of this structured information that's pulled from the invoice. And then I'm also getting the visual grounding information. So we'll see these chunk references later, but when you're using the API, you'll be able to save the individual portions of the document as a chunk and refer back to it later or display it for the user for verification purposes. So I guess a couple things to summarize before we move on. So this is the visual playground. It's for experimentation and accuracy checking. Makes it very easy to put things side by side. This is running in our cloud service, so you should not be using any sensitive documents. Everything I'm showing today are documents we've found on the internet. If you do need enhanced security to be able to properly test your own documents, absolutely contact us because we can make that possible, and we want you to be able to test on your own real documents. When you drop a document in here, you're going to get a Markdown response and a JSON response. This particular JSON response corresponds to the chunks, and so it is kind of based on the layout of the document. Contrast that to this other JSON response, which is now based on the specific fields that you want from the document, but will also provide the reference to which chunk contained any particular piece of information. Okay, let's move on. So we looked at a lot of the core examples. I'm going to show just a few of these archival examples. This is one that we put out on 4th of July. It's a historical document. It has some interesting handwriting on top, which is correctly recognized. And this document also has some damage or just issues with scanning. So you can see how blurry it is over here on the left-hand side. I'm not going to read you this extraction, but it did actually get pretty much all of these words correct. It's easier to verify on these names. So, you know, this might be a water droplet or some other damage. So this is an example of working with slightly damaged or distorted or wrinkled historical documents. Here's another example, which also adds the element of somewhat grainy picture and handwriting. So this particular one is a death certificate from a county records office. So again, not the greatest original like scan or photography quality, and also a lot of handwriting involved. But if you kind of click around on this, you actually notice that it's quite accurately extracted. One more historical document. This has a lot of the same features as the previous examples, but we do encourage you to try some of your kind of damaged and distorted documents. They are often being extracted quite nicely. And you can also get a nice figure extraction around some of these stamps. Okay, let's do a time check here. Okay, let's move on to difficult tables. So just a couple examples here before we get into actually working with the API. So many of our demonstrations actually just deal with research on the common cold, right? I had to pick some sort of topic that, you know, nearly every audience would be interested in. So You'll probably see our common cold documents in various demonstrations. But this particular table has a couple unique features to it. So one, it has multiple header rows. So this like percent of patients positive by like actually covers these four columns. And so the headers are extracted correctly. And then the rows have no particular grid lines. So we see a lot of these tables with lots of white space, especially in scientific documents. And so being able to extract that correctly has been a problem with OCR. Um, Here's another example, a few things to highlight here. So this document natively has a three-column layout, but then this photograph and this caption actually interrupts that three-column layout, but that is extracted correctly. One of the problems with a lot of traditional OCRs, it would read kind of across here, and so you would get an extraction that says the lack of effect of figure 1, 500 milligrams, right? And it would not recognize that these are distinct text chunks. There's also a difficult table in this example. So the reason I consider this one difficult is because the shading in the original is actually somewhat misleading. So if you look carefully at the original, this first row, number of trials 29, is then subdivided into 23 and 6. So the first three rows actually all deal with this first outcome. And that is extracted correctly over here, that all three of the three top rows are associated with this first outcome. So we've seen lots of great examples of difficult tables, and our product team is continuing to focus on tables. Another thing I'll say about tables is right now, in terms of the visual grounding, right? If you asked like how many participants were in the trial, it would return the entire table as the chunk reference. We will be introducing what's called a cell reference to actually be able to say like which cell in the table that value came from. And that's important if the number is in a very large table. It's hard to visually verify the accuracy if the table, has like 90 values in it. So we want to be able to return exactly where in the table that the information came from. Let's take a look at some charts. Advanced charts. And so, oh, there it is. Okay. This is probably my favorite document to demonstrate with. It's an equity research report about Expedia. It's 18 pages. The reason it's my favorite is the diversity of chart types that are used in one document. So let's just look at a couple of them. So, of course, we expect good performance on something like a pie chart, right? So the summary is going to tell you this is a pie chart. It's going to extract the different data points. It's also going to give you an analysis of what the pie chart means. So notice that in this figure, there is no caption to say like, what is the insight from this figure? But in the analysis, it will say, the revenue is heavily concentrated in the US, which is significantly smaller shares, right? So for the figure extractions, you're getting the values from the figure, but also an analysis of what it means. So this document also has line charts. This document has spider graphs. It has a SWOT analysis chart. You can see why it's my favorite, right? It has this line chart with a lot of different callouts. It has these kind of unusually shaded tables. Is a box plot. Right. So you get the idea here. So one of the reasons that we're seeing so much interest in our agentic document extraction is you can trust one API to handle all of these diverse types, right? There's also these like very small tables with very small fonts. So a document like this would otherwise be an extraction nightmare. There's text, there's tables, there are many different chart types. So being able to send this all to one service rather than having to break it up and use different services is a huge part of the value here. What else do I have for advanced charts? In scientific documents, there are often like chart types that you don't encounter, natively in Excel or other charting like business intelligence tools. Flowcharts are very common. So what I like about the flowchart extraction is it'll show you the nodes and the connections for any particular flowchart. Lots of tables. This forest plot analysis, right, is also not a common chart type. What I like about this one, in addition to getting all of the values back, the analysis also says that the majority of studies suggest a reduction in the incidence of common cold with echinacea with an odds ratio of less than 1. So it actually understands what is meant by a scientific meta-analysis, that this is looking at the effect sizes of many different studies and then applying a statistical analysis to say what is the effect size considering all of these studies combined. This document also has what looks like a scatter plot initially, but is not. It's a specialty type of plot called a Labé plot, which I had to look up the pronunciation. But this is kind of in my advanced charts section just to illustrate understanding on scientific charts, which are a little bit less common. Okay, last thing we're going to look at is some languages, and then we're going to move over to doing some things in the API. So I'm a native English speaker. Many of our examples are in English, but we're taking so many phone calls from all over the world, and people are reporting that the extractions are really high quality in other languages. This is kind of a preview of the food example that we're going to do together. But what's interesting about this product package, it has multiple different languages in the text and in the table. It also shows kind of extraction against a clear background. And for any of you who actually speak these languages, I encourage you to pause the recording and take a look at the accuracy of the extractions. A few more language examples here, mixture of English and Japanese. More language examples. I'm not able to read any portion of this one. I'll leave it on screen for just a moment. More language examples. Here's a handwritten German. And what else did I have? Yes. So here a Spanish language waybill. Right? All right. So just wanted to emphasize that this solution will work with documents that have a mixture of languages and is working very well on a wide variety of languages outside of English. Okay. Adrian, we want to take like one or two questions before moving on?
That is great. Let's kick off with the first couple of questions. The first one is it multimodal also, specifically to video understanding?
Right now, the input types are PDF, PNG, JPEG. We're going to be adding support for Word documents and like Excel files. So I don't believe there's any plan to accept video as an input. You would first have to grab a certain number of frames per second from the video as images, and then the images could be processed.
Great. Let's take the second question. This may be covered shortly, but I'm very interested on how LandingAI combats hallucinations and or handles the output. Is human review needed?
Yes. So the way that we combat the hallucinations is by providing the grounding information. So we're about to take a look at using the API, but here for these kind of user supplied documents, What I'm getting back is the grounding. We saw this Fidelity account statement earlier. It's 28 pages. Right? And then these are all of the individual chunk IDs, which were highlighted in the playground. So if a value was extracted, such as like the total balance in this investment account, that number would have a chunk reference associated with it, and that chunk reference would have an image associated with it, so it can be visually verified. Now, of course, you don't want to verify like all of these individual PNG files. So the direction we're headed is introducing a confidence score. And we're expecting that people will use that in a human in the loop process where only things below a certain confidence score are reviewed. But it will be very easy to say, this value came from this chunk. And by the way, here's the picture of just that chunk.
Excellent. Do you want to take one more question or jump back in the
Sure.
presentation?
Yeah, this is good.
Okay. If I'm taking high resolution images of large equipment with small metal plates with the manufacturer's data on it, would you see any limitations on the scale of the data versus the overall image, even if the data plates are quite small in the grand scheme of the image?
Um, I have been on demos where people are using kind of architectural drawings or engineering drawings, and the results have been mixed as you're getting into these small details. So I think the key is just to try it on your particular documents. Some of these like architectural engineering drawings, the details are clear enough that they come through in the extraction and sometimes not. So it's definitely a category of hit or miss. Yeah, just to be truthful, so just try it.
Okay. One more question.
Sure. Yeah.
Okay. Can you please explain the methodology used for creating chunks in document extraction? Specifically, how do you decide the chunk size and boundaries, and what strategies are used to ensure the chunks retain context?
Okay, excellent question. So you may have noticed that we actually have a fairly limited number of chunk types. So in the colors here, there's purple for marginalia, pink for figure, green for text, and blue for table. Those are the only current chunk types. When we first introduced the service, we had many other types, and it actually just became too difficult to rationalize. But now we've realized that everything does fit into either text, table, figure, or margin information. So we do have a foundational model which first understands the layout of the document and assigns one of those four types. I'm guessing from the nature of your question that you've done some RAG pipelines where you have to apply your own chunking strategy, which is often based on like punctuation or just like, every 100 characters with a certain amount of overlap. This will kind of do away with the need for that and it will keep things together. So if I go back to maybe one of my scientific documents, um, so here, rather than just saying like, let's break this chunk at every sentence or let's break it every 200 words, here, like you actually have the subtitle stays together with the text below and the subtitle stays together with the text. So this should actually provide better performance for a RAG model rather than applying like a non-intelligent chunking strategy. Okay, let's talk a little bit about documentation and kind of user support, and then we're going to get into the code portion. So all of our documentation is available at docs.landing.ai. When you go to that homepage, it will automatically default you to Agentic Document Extraction, but you can also access documentation for our other products here, or if for any reason you're in this one and you need to get back to Agentic Document Extraction. So definitely read through the overview, read through the quick start. We've really update these docs almost daily, like you see updated, updated, new. And so this is in response to questions that people are submitting, like where are they getting stuck? Where are things not clear? So we're constantly adding to the documentation. Another place to get information is directly from the GitHub link to the Python library. So this will link you back to the documentation. It'll link you back to the Playground app, but there's also a variety of information here and additional quick start references. Another place to get help is the Discord community. So let me show you actually how to get there. So you're all automatically invited. So if you expand this area and you go to your little person icon, down here, the community with the Discord icon, if you click on that, you will be automatically invited to join the Vision Agent community. So on the Start Here page, there's a bunch of information about how to get the most out of this community. So there is a bot which can try to answer your questions in the moment. This has been trained on all of our documentation. And so if you want to ask the bot a specific question, just ask away. It should provide a very good answer. Need human help? There's a channel for that. If you are a current paying customer, there's a one-on-one support ticket that you can create. And of course, introduce yourself, learn from others. People are doing some really creative things with agentic document extraction. OnKit is our community, sorry, developer relations specialist. And he is in here all day long to help people like learn Discord if it's new to you and get value out of the community. So this is really for users of all sizes, whether you're very small or enterprise level. And then let me also refer you to where to get the trust and security information. So most websites, if you scroll all the way down to the footer, are going to have some important footer links. So if you need this kind of trust and security information, it's down here in the footer. That'll take you to this page where you can learn a little bit more about HIPAA compliance, SOC 2 compliance. We are working on obtaining these certifications. They should be available shortly, and then it'll be updated on this page when they are. We also mentioned data security and zero data retention. So this is an option for customers with high privacy requirements. So those healthcare, financial services is definitely going to require zero data retention. And in that case, they are used exclusively for the extraction process and immediately discarded. So there is no storage by our systems or by any of the sub-processors. Okay, so I'm not going to read you the entire Trust and Security Center, just important to know that it's here and there's a lot of great information that your legal teams will inevitably ask you at some point. I think we're going to transition to doing some things in code. So don't be scared by some code. All of this should make good sense. So one of the demonstrations we're going to look at is being able to provide just a set of documents. So imagine that we've provided 4 documents that a user has submitted to go along with their loan application. So their pay stub, their bank statement, their last W-2, right? And we want to extract everything related to loan 7. So what you're going to get back will be results. So just like we saw in the playground, you'll get a JSON response and a Markdown response for every document. You'll also get the visual groundings for any of the chunks found on those documents. So here's everything from the first page of the earnings statement. And optionally, you can get the chunks overlaid on the original. So this is also an output from the API. So pretty much everything that we saw in the visual playground is available as an API output programmatically. What you're seeing here is just one of those documents open. So we've got the original JSON response from the W-2 file, and then there is the Markdown portion. Okay, so let's do a little bit of parsing. And I'm going to let you watch some of this as it happens. Okay, I may have to adjust my windows a bunch here. All right, I think that's going to work. I'll make the notebook smaller. All right. So these first four lines are very common Python libraries. The key thing to note here is from Agentic Doc parse, import parse, and then visualize the parse document. So let's go ahead and run this. So I've already set my API key as an environment variable. So definitely check this line that the API key is set correctly. All right, this cell is just going to create some additional folders. So you saw some folders created over here just to hold the results. So let's take a look at the files that are in the input folder. So here I'm just reading the files that are in the input folder. You see them over here. They're actually some pictures of products. Let me actually show you some of we saw these on the slides earlier. So got a couple different products here. All right, so six documents, six photographs. So this is the API call here. So we're going to use the function that we imported, parse. We're going to send all of the documents in the file path. So we're going to send all six of them simultaneously, and the library will actually parallelize all of that work for you. So they will be executed in parallel rather than in series. We're going to save the results into the folder we just created. We're going to save the groundings into the folder we just created. And then these are two optional parameters. Some people don't want all of the margin information. So let's go ahead and run that. So API key is valid, parsing six documents. And we should start to see some things appearing in these folders as well. All right. So it's as simple as that, right? So six was a reasonable number for demonstration purposes. They're all just a single page. But you see how you could load up all of the files you need to do in a batch process, run this every hour, every evening, whatever suits your use case. All right, let's take a look at some of these results. So you're going to get back a custom object with all of these parsed documents. I'm just going to look at the second one in the list, or which is actually the Python third one, right? It's the Goji Berry product. And we can display some of that on screen. So this is really just taking a look at what is in this long response, right? Because it's very hard to look at in this format. All right. You may want to extract, just some other information from the response. So the document type is an image. It's page 0 to 0, which in Python language means it's one page. There were four chunks found. And here I'm just printing like the first 500 characters of the markdown just to visually inspect it. This is just a little bit of parsing to understand what's in the response, right? So this told us that there's four chunks, and now we have a pandas data frame of those four chunks. So each one has a chunk ID, has a chunk type. We've got the image path, which corresponds to where on my file system that is now like saved, and the bounding box coordinates, which is where on page 0 did this chunk occur. Okay, we're going to skip some of these parts in the interest of time and get down to field extraction. Okay, so why did I choose these product images for a demonstration? One, it's kind of fun, and two, like nearly everybody does some grocery shopping and is used to reading health claims on labels. So when you look at any of these labels, in addition to the product name and the weight, there's a whole bunch of stuff like, does it claim to be grass-fed or organic or keto? And actually, should probably actually show some of the pictures a little bit bigger. So we did select some of these because they do have some of these like text on them. I particularly like this one because it's curved and it's kind of like disappearing off the edge, but it still gets extracted correctly. So, here's a zero sugar, here's a grass-fed claim, here's a grass-fed claim, regenerative, animal welfare certified, another grass-fed, right? So you get the idea that much like the financial statements or the health forms, these products, although they're visually very different, actually have like some of the same structure to them. So there's of course the weight information, but also these like USDA organic kind of things. So that's what we're trying to now do with this custom schema. So we've created a whole bunch of Boolean characters to say, does it claim to be grass-fed? Does it claim to be organic? And so on and so forth. So this is what we saw in the playground with kind of suggesting a schema. I started with the suggest schema and then I kind of modified it on my own. The more descriptive you are here in the description, the better the extraction will work. So if you're initially not getting exactly what you want, try varying the description. But let's go ahead and save that. And then we're just going to compare what we were doing previously. So this says do not run. This is the command that we ran previously to get the extractions for all 6. Now the only thing we're going to add here is extraction model equals product. So if I scroll back up here, I named this class product. So that's now what I'm referring back to. I could repeat these 4 rows, but I'm not going to because I've already saved the information. So here, result underscore feature extraction. Let's go ahead and send those. So this is going to take a little bit longer than the initial extraction that we saw because there's really 2 stages here. So the first stage is returning the markdown and the JSON that corresponds directly to this image. And then the second step is applying the schema to actually be able to extract all of the structured information we've asked for. And, we've asked for about 20 different things. I've seen some schemas get as long as 300 or 400, and they can have nested levels as well. You can nest up to 5 levels. Okay. So this looks like it's done. So we can print that to screen. So this initially looks like the same response, but if you scroll all the way over, you see now that our custom schema is in here at the end. So one of the nice things when you're unfamiliar with a data structure is you can just start exploring, what is in here. So all of the custom schema fields will be in this metadata section. Let's see. Oh, you're in the metadata section. Now I'm having to find them myself. Um, Okay, I'll just post an update along with this. Clearly, there's a lot of information in the extraction. But what we want to do here now is just create a nice table out of it. So for every record in my results with feature extraction, I'm going to go through and create a nice table out of this. So let's just go ahead and run that. And we have our table. So this, if you look carefully, is using pieces from the extraction and from the extraction metadata. You saw me kind of fumbling around up here with where exactly in extraction metadata the information is, but this, should verify that it's in there. And then I've included some examples like for USDA inspected, which I think is the final column. So there's the Boolean of true false, but then I'm also choosing to return the chunk reference. So when the response is false, of course, it makes sense that there is no chunk reference. But when it's true, then I have that chunk reference available. And that would allow me then to match it up with, not sure what that second line is, but Sorry. So that would allow me to match it up with these extracted figures if I needed to visually verify that extraction. Okay. I'm going to show one more thing, which we've already laid the foundation for, and then we'll open it up for questions. So the last thing I'm going to show is this Streamlit application. So this is using our library, a few other common Python libraries, and it is a Streamlit app. You're going to see this running locally on my computer, and let's just take a look at it. So from here, I'm going to start my app. It's going to open up locally. And what is this app? So this is really a generic kind of multi-purpose way to extract everything that's in a folder and put a user interface on it. So what we saw with the product demonstration was, 6 files in a folder, but then I stepped through it programmatically in that notebook. A non-technical user is going to need some sort of user interface. So that is essentially what this is. So it allows the user just to say, hey, like all of the documents that are in a particular folder, I want to send all of those for extraction. So here's this particular folder. So this is going back to that kind of loan example where a person has provided these files and you saw like the end result of it. But this is one way that a non-technical user could start to interact with the API. So I'm just going to provide the route to the folder, right? This might be like loan number 77, and then I'll hit begin extraction. So all of this kind of commentary text is just there to tell the user, hey, something is happening in the background. So you can see some of the folders being generated here. And if I find my terminal, where'd my terminal go? Yeah, so you can see like the processing happening. And then pretty soon in the UI, we'll start to get confirmations back to the user. So all of this is like we already laid the foundation for how all of this works. So test a document in the playground, get your API key, import the Agentic Doc Python package, play around with it in like a Jupyter notebook just to make sure everything is working correctly. And then you can put like a nice wrapper UI on top of it. So here, a non-technical user just had to provide the path to a folder, and you saw all 4 of these documents being processed in real time. So I now have all of the grounding information and all of these results, and also the overlay if I want them. So I can go to the W2 one, for example. So here's a text, 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 right? So there's lots of different chunks found here. Um, this particular app, I also, I'm just printing some of this information to screen. And you can tab through the 4 different documents. Same with this. This is really just for convenience, but it's an example of building an app. Like this took me probably about 1 day, and that was before our documentation is as good as it is now. But it becomes like immediately useful to extract everything that's in a folder. All right, I'm going to stop talking there and see what questions we have. And if you're still with me 55 minutes later, thank you. It was an ambitious agenda, but we really covered a lot.
Excellent. Let me kick off the next question. How is extraction accomplished? Object detection plus segmentation plus OCR.
So I work in the team that helps customers achieve technical success with the product. I don't actually know as much about the engineering of how we're accomplishing this magical result. It sounds like you're familiar with traditional computer vision, right, which has object detection and segmentation. We are fundamentally a computer vision company. Those are our roots. And we are treating the document using the core technology from deep learning, like we're treating it as a picture that happens to have some structure to it, rather than a document that happens to have a layout to it. So I don't have a clear answer for you. I also don't know how much we're actually sharing the secret sauce. I think we're really just encouraging people to look at the end result, give us feedback on the end result, like if we're missing a table extraction, if we're missing a particular language, and it's just going to get better over time.
Excellent. For graphs, like the pie chart in the 28-page document you shared, do we also get the config for the graph, for example, a JSON config for the graph, or do we only get the description of the graph as text?
You would get the latter. You're not going to get something that would allow you to reproduce the chart.
Next one, what is the difference between JSON result from parse and extract schema?
Yes, I tried to explain that. So the JSON response from parse follows the structure of the document. So it might be like the first chunk was text, and like here's the information in that first chunk. And maybe it has like company name and it has company address, right? But they're both in the first chunk. When you map that to a schema, now like company name and company address are going to be two different things in the schema. They just both happen to have been found in the first chunk. So the initial response just follows the structure of the document, and then the extracted JSON follows the structure that you ultimately want with a reference back to the first structure, if that makes sense.
We have time for one more question.
Yeah.
Do you offer local deployment of your service? As an example, in my own data center, this is due to confidentiality of our docs.
Yes. So in addition to the Snowflake option that I already mentioned, we can install in a customer VPC for AWS, Azure, and GCP. That is a much longer process to get started, right? Because we're doing a custom install for you versus just working with the cloud API, but that is an option.
Excellent. We are at time. Andrea, thank you for a fantastic presentation, a very interactive session. Thank you for joining us, and we are at top of the hour. Thank you. Have a great Wednesday.